Why the constants of nature have their values. Have you ever had one of those moments of pure, silent awe? Perhaps you were lying on your back in a field, far from the city lights, looking up at the tapestry of the Milky Way. The sheer scale of it is overwhelming. Billions of suns, countless worlds, a cosmic dance on a stage so vast our minds can barely comprehend it. In that moment, a question might whisper at the edge of your consciousness. A question so profound, so fundamental, that most of the time we dare not even ask it. Why is there all of this? And more specifically, why does this work exactly the way it does? Today, we are going to dive into what I believe is the deepest, most beautiful mystery at the heart of reality. It's not about the things we see, the stars, the galaxies, the atoms. It's about the invisible rules that allow them to exist in the first place. We are going to talk about the constants of nature. Imagine, for a moment, that the universe is a sublime, impossibly complex piece of music, a cosmic symphony. The planets, the stars, the very atoms in your body. They are the notes, the melodies, the rhythms we can hear. They are the output. But what about the sheet music? The fundamental score upon which everything is written? That, my friends, is written in a language of numbers. A set of fundamental, unchanging values that are woven into the very fabric of space-time. These are the constants. Think of the force of gravity. We all feel its pull. But how strong is that pull? The strength isn't random. It's set by a number. A very specific, precise number. The same is true for the strength of the glue that holds atomic nuclei together, the speed of light, the mass of an electron. These are not things that evolved. They are the foundational settings of our reality. And here is the part that should send a shiver down your spine. These numbers, they are perfectly tuned. It's as if some cosmic architect, at the moment of creation, dialed in these values with unimaginable precision. Let's play a game, a thought experiment. Imagine you have a universe creation control panel in front of you. It's covered with dials. Each dial controls one of these constants. One dial is for the strength of gravity, another for the power of the electromagnetic force. Another sets the mass of a quark. Now you close your eyes and give those dials a random spin. What happens? In almost every single case, you get nothing. A dead, sterile, boring universe. If gravity were just a tiny bit stronger, all the stars would have burned out billions of years ago, their fuel consumed in a frantic, furious blaze. If it were a tiny bit weaker, matter would never have clumped together to form stars and galaxies in the first place. The cosmos would be a thin, cold, eternal fog of hydrogen. If the nuclear forces were slightly different, the elements of life, carbon, oxygen, nitrogen, would never have been forged in the hearts of stars. There would be no planets, no water, no chemistry complex enough to lead to you. This incredible, razor's edge balance is what scientists and philosophers call the fine-tuning problem. It's the observation that for a universe to be stable, long-lived, and complex enough to give rise to conscious observers like us, the constants of nature must fall within an astonishingly narrow range. It's like winning the cosmic lottery 1 trillion times in a row. The odds are so astronomically against it that it beggars belief. So, what's going on? Throughout human history, when we've been confronted with a mystery of this magnitude, we have offered answers. And these answers tell us as much about ourselves as they do about the cosmos. The first, and perhaps most ancient answer, is the divine architect. The idea that the constants have their values because a conscious, intelligent designer chose them. This is the universe as a deliberate creation, a work of art. The constants are the signature of the artist, the proof of purpose and intent. In this view, we are not a cosmic accident, but part of a grand, meaningful story. The numbers are what they are because they were meant to be, so that life, and perhaps even us, could one day look back and wonder. It's a powerful, comforting narrative. It gives the universe a why. Then, with the rise of modern science, came a second, more austere answer. Let's call it the cosmic coincidence. This is the idea that there is no reason. The numbers are what they are simply because they are. It's a brute fact. We are the lucky ones who just happen to be in the universe that worked. In this view, asking why these numbers is like a lottery winner asking why they won. The answer is just chance, a staggering, meaningless fluke. There is no deeper meaning, just the cold, beautiful, and indifferent laws of probability. This view can feel lonely, but it has a certain stark, intellectual purity to it. But then, in the last half-century, a third, far more radical and mind-bending possibility has emerged from the frontiers of theoretical physics, an idea so strange, so magnificent, that it makes the idea of a single universe seem provincial. This is the multiverse. What if our universe, with its perfectly tuned constants, is not the only one? What if the Big Bang was not a single, unique creation event, but just one bubble in a frothing, infinite cosmic ocean of bubbles? An endless foam of universes, each with its own unique, random set of physical laws and constants. In this vast multiverse, the dials on the control panel are spun an infinite number of times. In the overwhelming majority of these universes, the numbers are wrong. They are stillborn, or empty, or fly apart in an instant. They are cosmic ghost towns. But in a tiny, tiny fraction of these universes, by sheer, unimaginable chance, the numbers line up. The constants are just right for stars to shine, for planets to form, for chemistry to dance, and for life to emerge. In this view, there is no fine-tuning. There is only a cosmic selection effect. We must find ourselves in a universe that can support us. We are not lucky. We are inevitable, in the sense that conscious observers will only ever awake in the places where the laws allow them to exist. We are the universe's way of becoming aware of itself, but only in the rare neighborhoods where such awareness is possible. This is not science fiction. It's a serious, though highly speculative, consequence of our best theories of the early universe and quantum mechanics. Think of it like this. If you are a fish in the ocean, you might look around and marvel at how perfectly water is suited for you. It's buoyant, it has oxygen, it's the perfect temperature. How fine-tuned. But then you peek your head above the waves and see the vast, dry continents, the frozen poles, the toxic lakes. You realize your watery home is just one possible environment in a much larger world. The multiverse theory suggests we are that fish, just beginning to suspect the existence of land. But the multiverse is just the beginning. It leads us to even stranger shores. What if the constants aren't constant? What if they have changed over the immense lifespan of the cosmos? Some scientists have proposed that in the first fleeting moments after the Big Bang, the laws of physics were more fluid, and what we now see as fixed numbers simply froze into place as the universe cooled, like a crystal forming from a liquid. Perhaps there was a kind of cosmic evolution where different sets of constants competed, and the one we live in was somehow the most stable. Or, let's go even deeper. What if the constants are not fundamental at all? What if they are emergent? Consider a whirlpool in a river. The whirlpool has properties, a size, a speed, a shape. But these properties aren't written into the fundamental laws of water. They emerge from the complex interaction of countless water molecules flowing over a particular rock formation. The whirlpool's constants are a consequence of a deeper, simpler level of reality. What if our universe is like that whirlpool? What if the speed of light, the strength of gravity, the mass of an electron are all emergent properties, the surface appearance of a reality that is far stranger and perhaps far simpler at its core? This leads us to some of the most futuristic and magical ideas in all of science. The holographic principle, for instance, suggests that our three-dimensional reality, with all its richness and these precise constants, might be a projection from information stored on a two-dimensional surface at the edge of the universe. The constants in this view would be like the resolution and color settings of a cosmic projection. They are the parameters of the simulation. Is our universe a computation, a cosmic hologram? If so, who or what is running the code? And why these lines of code? So, where does this leave us? With four profound possibilities, each more wondrous than the last. 1. A designer, a universe with purpose, meaning, and a divine mind behind the curtain. 2. A coincidence, a universe of breathtaking, random beauty, where we are a fleeting, precious accident. 3. A multiverse, a reality of infinite possibilities where we are but one lucky island in a boundless archipelago of existence. 4. An illusion, a universe where the constants are not fundamental, but shadows on the wall of a deeper, hidden reality. Which one is true? We don't know. And that is the most exciting part. This is not a closed book. This is the great, open question of our time, perhaps of all time. We are the first generation of humans to even have the tools to ask these questions in a scientific way. We are cosmic children, just learning to read the first few words of an epic that spans all of time and space. The search for the answer is a grand human adventure. It's what drives us to build particle colliders that recreate the first moments of time and telescopes that peer back to the dawn of creation. We are not just studying the universe. We are trying to read its source code. And you are a part of this. The very fact that you can sit and ponder this question, that your brain, a collection of atoms forged in a long-dead star, can contemplate the fundamental rules that allowed that star to exist. That is a miracle in itself. You are the universe becoming self-aware. You are stardust, trying to understand its own origins. So the next time you look up at the night sky, don't just see the points of light. See the invisible architecture. See the perfect, precise numbers that hold it all together, and wonder. This journey into the heart of reality is one we take together. If this conversation sparked a sense of wonder in you, if it made you see the world a little differently, then please help this channel grow. Like this video and subscribe to the channel. It truly helps us continue to explore these profound mysteries. And I want to hear from you. The mystery of the constants is for everyone to ponder. So, comment down below. Which of the four possibilities resonates most with you? The designer? The coincidence? The multiverse? Or the illusion? What is your intuition telling you about the source code of our reality? And for those of you who want to dive even deeper, to explore the furthest frontiers of this idea, especially the holographic principle and the multiverse, I've written a book that expands on all of this. It's called Holographic Multiverse. In it, we journey together through the science and the philosophy of these ideas, connecting the dots in a way I think you'll find truly thrilling. If you're interested, the link to get your copy is in the description below. Thank you for watching, for wondering, and for being a part of this incredible quest. Remember, the universe is stranger and more magical than we can suppose. Our adventure to understand it is just beginning. Until next time, stay curious.